Hey, welcome back to Math with Patrick and Quill. Today is August 18th, and we're solving problem number 230 from the Daily Epsilon calendar. And the answer for today's problem should match today's date, so we should get 18 at the end of the video. We just need to find the sum of the digits of 1,000,002 cubed. And I can't think of any tricks to this one besides just trying the computation for ourselves and seeing what happens. I think maybe for my 1 million time or 1,000,002 times 1,000,002, I'll use an area model. And then let's see what I feel like doing when we multiply the third and final 1,000,002. So I could write 1 million here and then a 2. And then here's another 1 million and then a 2. And the whole idea behind the area model is if I wanted to do 1,000,002 squared, I could just find the whole area of this square. And to find the area of this square, I could decompose it into 4 parts. And for me, sometimes it's easier to just multiply numbers this way when I can do it one part at a time. So 2 times 2 is 4, 2 times 1 million is 2 million. And then we're going to have another 2 million right here. And then 1 million times 1 million is going to be a 1 with 12 zeros after it. I'm essentially just looking at all these zeros, tallying them up, and then writing how many zeros I see. And then, let's see, if this would be 1,000, then that would be a million, that would be a billion. So this is 1 trillion right here in this top left square. And then the last step with this area model is just to add up your 4 parts. And so I'm going to have a 4 and then a 2 million. Oh, 2 million. So I guess we're going to have 4 million. So something like that. And then I need to write the trillions as well. So I think I need 3 more zeros, it looks like. And then the 1. All right. So now we have 1 trillion, 4 million, and 4. That's apparently the same thing as 1 million and 2 squared. And then now we just need to multiply this by 1 million and 2 again. So I guess the multiplication could look like this, although I don't really want to do it this way. I think instead I'd rather do it with some kind of distributive property here. I'm thinking what if I multiply it by 1 million first and then the 2 second? And so by multiplying this number by 1 million, I'm essentially going to introduce 6 more zeros tacked on to the end. So I'm going to get 0, 0, 0, 0, 0, 0, and then this 4 is going to go right here. Then we're going to get these 5 zeros, 1, 2, 3, 4, 5, and then this 4 will move right here. And then it looks like we have 5 more zeros, 1, 2, 3, 4, 5, and then a 1. I'm not sure what to call this number. It's definitely more than a trillion, probably somewhere in the quadrillion or what's the number for 5? I don't know. Anyways, it's a big number. And all I really need to do is add up the digits of this number, so I don't need its name. Anyways, so we did this multiplication right here, and now we need to add it to this multiplication here. So I'm just going to double the original number that we had, and that's going to be fairly easy. I'm going to ignore the zeros actually, and I'm just going to double that 4 right there, and then I'll double this 1 right here. And I guess I need to add these 2 numbers together to make sure that I actually get the base 10 representation of whatever this number is. So we have 8. We have 5 zeros in a row. And again, I'm not really caring about these just because we need to add up the digits in the end. So if there are zeros, I don't need to write them. 8 plus 4 is going to be a 12. That means we have 4 zeros right here. 4 plus 2 is a 6. We have a whole bunch of zeros, well, 5 of them. And then finally the digit 1. So we can add these 2 numbers together. We get 20. We can add these. Wait a sec. That's not how it works. We're going to add these 2 digits together. We get 10. And then we're going to add the 1, the 6, and the 1. Again, we're adding digits. And that makes 8. And then if we add those 2 numbers together, we get 18. And that is today's date. So 1 plus 6 plus 1 plus 2 plus 8, those are and all the zeros that I didn't write, those are all the digits in this kind of really, really long number, and we get 18. So there's my answer. Pretty straightforward, I think. The only hard part is just keeping track of all the zeros and the place values. Well, thanks for watching, and I'll see you tomorrow. Bye.